Hello everyone, this is Rita from Beijing Sino High Tech. Today we're gonna have a training on the hydrogen industry and the hydrogen applications. Through today's training, you can have a glimpse of the hydrogen development in China. And in the future, we can have more discussion and cooperation in this regard. In today's training, we will mainly have two parts. The first part, we will introduce hydrogen industry, and application scenarios. First, we will introduce the hydrogen industry. We will talk about the hydrogen development-driven factors, the hydrogen development in China, and the global background, and the hydrogen growth potential. Second, we will talk about the hydrogen industrial chain. We can focus on hydrogen production, hydrogen transportation, and hydrogen power generation. In the third part, we will talk about the hydrogen application scenarios from transportation to hydrogen storage, from industry application to architecture sector application. Then we will focus on hydrogen safety at the hydrogen level as well as the vehicle level. And next, we will have a brief introduction of our company, Beijing Sino High Tech. So first, let's have an overview of hydrogen industry. As we all know, it has been a global consensus that 35 countries and regions have issued hydrogen energy development roadmaps and actively support hydrogen energy and the fuel cell industry. For example, like China in 2022, we roll out the medium and long-term plan for the development of the hydrogen industry. Before the global commitment and action, there were energy crisis and energy transformation. At the end of the 19th century, before the Industrial Revolution, the consumption of coal surpassed the energy consumption of traditional biofuel. And at the first half of the 20th century, because of the application of internal combustion engine, the energy consumption of oil and natural gas surpassed the energy consumption of coal. And today, the energy mix is still transforming. We want to use more renewable energies like the solar, wind, and hydrogen. Because we have the zero carbon emission and carbon neutrality policy, we must control the temperature increase within the 2 Celsius degree compared to the pre-industrial level. So if we go with the current carbon emission level, it will surpass and the energy increase will reach 2.6 to 3 Celsius degree. If we control and follow this map, we can follow this map set by the Paris Agreement. We can control the temperature increase within the 2% below the red line. So why is hydrogen? Because hydrogen is power to X. With abundant renewable energy as the source power, hydrogen energy has provided sustainable solutions for transportation, metallurgy, chemical, power grid, and other industries, creating a wide range of application scenarios and driving the energy transformation era. We use hydrogen lithium power to the power grid and also power to the transportation industry. Also from the market potential perspective, we can see from this picture in 2050, the application of hydrogen will increase to 10 to 15%. And the mainly used sector is the industry sector. So how about the hydrogen development in China? There are several reasons that contributed to the quick development of hydrogen in China. The first one is the favorable environment in China, because China is a large hydrogen producer and consumer. It's predicted that in 2030, the hydrogen demand in China will reach 35 million tons, and in 2050, that figure will reach to 60 million tons. And the annual hydrogen production in China accounts for 1/3 of the world. Next reason is from the national level and the local level policy support. As we said in the roadmap, that China rolled out the medium and long-term plan for the development of hydrogen energy industry from 2021 to 2035. It says that in 2025, the numbers of fuel cell electric vehicles is about 50,000. The amount of hydrogen produced from renewable energy reaches 100,000 to 200,000 tons per year. CO2 reduction reaches 1 million to 2 million tons per year. In 2030, a relatively complete hydrogen energy technological innovation system, clean energy hydrogen production and supply system will be established. And in 2035, a hydrogen energy industry system covering transportation, energy storage, and industry and other fields. The proportion of hydrogen production from renewable energy in the final energy consumption has increased significantly. And the last reason is about the abundant renewable energy. From this picture, you can see in the northwest China, there are abundant solar and wind energy. Next, we will focus on hydrogen industrial chain. For the hydrogen production, we know there are 3 types of hydrogen: the green hydrogen, blue hydrogen, and the green hydrogen. The green hydrogen is mainly used oil or natural gas, fossil fuels, coal to produce the hydrogen. And the blue hydrogen use the carbon capture technology, while the green hydrogen may use renewable energies like solar wind to produce green hydrogen. So we can see there's data from 2020 that in China, the main source of hydrogen production is still coal, and in the world is still natural gas. But it is predicted that water electrolysis will increase to 60%, and the natural gas with carbon capture, utilization, and storage technology will increase by 40% in 2050. Except for coal and natural gas hydrogen production, there are also coke oven gas production, hydrogen production, and color alkali to hydrogen production. These are all green hydrogen. So far, the fossil fuel-based hydrogen production is still the mainstream in China, while water electrolysis stands for a promising industry in the future. There are several ways of hydrogen production. So from the alkaline ways is a more developed technology, low cost, large scale application, but it still needs stable power supply. And for the PEM water electrolysis, it has flexible operation, small size, high output pressure, and uses renewable energy. But the disadvantages is that it uses precious metal as the catalyst and also limited by the supply chain. And for the SOEC, it has a high conversion efficiency, but is still in the labo stage. For hydrogen transportation, there are mainly three types of transportations, like long tube trailers, pipelines, and tank vehicles. Based on different status and hydrogen delivery and transportation ways, there are several types of hydrogen, like the gaseous hydrogen, 35 megapascal or 70 megapascal. The pros are it is quite developed and efficient technology. It has a lower cost and very easy to operate. But the cons are it's very flammable and has safety concerns, high requirement of hydrogen refilling, operation, and the surrounding environment, and also has hydrogen storage intensity. For the liquid hydrogen, it has to be cooled to temperatures below minus 253 Celsius degree, and mainly used in aerospace sector. The cons are it's very dangerous to handle and strict storage conditions, and will use higher energy consumption. For the methanol and NH3, it's low conversion efficiency, toxic, and higher energy demand. For the LAHC, it has a high energy storage density, easy transport, gas impurities, difficult dehydrogenation, and use catalyst and has a high working temperature. For the metal one, it's safe, has a high volume of hydrogen storage density, easy transport, but it has a higher cost and higher temperature for dehydrogenation. Based on different types of hydrogen, and there are also have different ways. Like the gases will use the long tube trailers to transport the hydrogen, and the economic distance is less than 150 kilometers. The pipelines, the economic distance for pipelines is more than 500 kilometers. And for those tank vessels, for liquid transportation, it can carry 7,000 kilograms, and the economic distance is more than 200 kilograms. For the metal one, the economic distance is less than 150 kilometers. And next, the hydrogen to power. Globally, SOFC and PAFC has been widely applied, while in China, PEM fuel cell with quick startup has been widely used in small-scale distributed home-based scenarios and has been improved from kilowatt level to megawatt level development. The comparison can be seen as follows. We can see the advantages of PEM fuel cell is that the working temperature is much lower from 80 to 100 Celsius degree, and the startup time is much lower than others, like it's less than 1 minute. And from the application scenarios, the PEM fuel cell can be primarily used in the passenger vehicles and the commercial vehicles. There is a summary of the pros and the cons. For the PEM fuel cell, the pros are it has a high power intensity, light and small size, long service life, quick and cold start. The cons are it's difficult processing, needs special fuel. For the SOFC, the pros are it has a high conversion efficiency, no precious metal catalyst, and fuel compatibility. The cons are it has a high temperature, easy corrosion, and low startup and short service life. For the PAFC, it's a quite developed technology and has entered into the commercial stage. It's a fuel with impurity. And the cons are it has a large size, has a lower efficiency, short service life with strong corrosion of electrolytes, and need precious metal as catalyst. For the MCFC, the pros are it has a high efficiency, few compatibility, but the cons are it has a high working temperature, corrosion of electrolytes, and a low startup and short service life. For the third chapter, we will focus on hydrogen applications. The mainly application is the primary application is the industry sector. And from this chart, we can see from more than 60% of hydrogen utilization is in the industry sector. From the ammonia synthesis to oil refining to metallurgy, all use the hydrogen. As we say, there are three types of hydrogen: green hydrogen, blue hydrogen, and green hydrogen. But if we want to achieve the carbon targets, it's necessary for the industry sector to shift from green hydrogen to green hydrogen. Because of the application of electrolyzer, and also the higher demand of electricity consumption, the renewable energy electricity, and the carbon tax, we can see from this chart the use of green hydrogen will increase in the future. And in the transportation sector is the next application case. Through this driving range, and we can see like more than 600 meters, the fuel cell electric vehicles will be the mainly support. And in the future, those middle to long-term distance, the fuel cell electric vehicles will be the main support. And actually, there are two types of fuel cell electric vehicles: the hydrogen internal combustion engine and the fuel cell electrical vehicles. There is a comparison between these two technologies. They do share some similarities, like the two technologies are both fuel cell powered with hydrogen and has zero carbon emission. But the fuel cell electrical vehicles uses the electrochemical reaction and only has water vapor as a byproduct. But the internal combustion engine will also produce nitrogen oxide. And the fuel cell electric vehicle has better environmental adaptability with cold start function. Well, the H2 combustion engine has a lower capability. And the fuel cell electric vehicle has higher energy density, better system efficiency, and quick hydrogen refilling times. The H2 ICE is similar to traditional combustion engine. But those two technology also has a longer driving range. For the fuel cell electric vehicle development in China, 2023 witnessed a record high in fuel cell electric vehicles production and sales, and the ownership is projected to reach 50,000 in China by 2025. From these two charts, we can see there is a increased trend of the sales and production of FCEVs in China. And as the prediction that by 2025, the number of FCEVs will increase to 50,000. For the FCEV future development, there is also a trend for the 5 years, 10 years, and 15 years. For the 5 years, there will be medium power fuel cell system plus higher power battery, and it will still be in a demonstration utilization. Well, After 10 years, there will be high power fuel cell system with medium power battery, and this system has entered into a commercialization stage. 15 years later, it will be full power fuel cell system, millions application in passenger vehicles and a commercial vehicle. Hydrogen production with renewables and supporting infrastructure will highly developed. In 2020, the fuel cell electric vehicles from the function description perspective, the cold start is minus 30 Celsius degree with optimized e-powertrain system. And the cost is equal to an EV. Well, in 2025, the cold start will be minus 40 degree with reduced cost with batch production, and the cost will equal to a hybrid vehicle. And in 2023, the performance will like a traditional vehicle and have competitive edge. For the commercial vehicle in 2020, the durability is 400,000 kilometers. The cost is less than 1.5 million RMB. And in 2025, the durability is 800,000 kilometers, and the cost is less than 1 million RMB. Well, in 2030, durability 1 million kilometers, cost less than 600,000 RMB. For the passenger vehicle, the service life will also increase from 200,000 kilograms to 250,000 kilograms and to 300,000 kilometers in 2030. The cost will be decreased from less than 300,000 RMB to less than 180,000 RMB in 2030. And there are also different factors driven to the rapid FCEV development. The first one is the advancement of fuel cell system technology. From this chart, the fuel cell cost will decreased from 700 to $300 to $85 per kilowatt in 2030. And the hydrogen fuel cell system power will increase from 30 to 80 kilowatts to 300 kilowatts, or even to 500 kilowatts in the future. And the rated point efficiency will also increase from 45% to 50% and then to 55%. The lifespan will increase from more than 10,000 hours to more than 20,000 hours, and then to more than 25,000 hours. The cold start ability will also increase from minus 30 Celsius degree to minus 35 Celsius degree, and then to minus 40 Celsius degree. Another reason is for the development of hydrogen refilling stations. From this chart, the number of hydrogen refilling stations in China and the world shows an increased trend. And in 2030, there will be more than 1,000 hydrogen refilling stations in China and more than 4,500 hydrogen refilling stations at the global level. And in 2024, in this year, there are more than 500 hydrogen refilling stations in China right now. Next reason is the cost downtrend of hydrogen. For now in China, the hydrogen is 40 to 70 RMB per kilograms. And in Japan, US, and EU, the hydrogen costed $10 per kilogram. Well, in 2030, it's projected that the hydrogen will be 20 RMB per kilogram. And China will also be a great supplier to America and the EU. The last reason is the supportive policy. In China now, there are 20,426 FCEVs and registered in China. And because of the supportive policy, the city clusters policy, there are 5 city clusters, like in Shanghai, in Beijing, Tianjin, and Hebei, and in Guangdong city clusters, also in Henan city clusters. There have tens of thousands of level the demonstration scale of the FCEVs. Because of that, there are a lot of global OEMs. We can see the Hyundai, Toyota, Honda, and the Daimler Truck, Volvo, BMW. They all have their own FCEVs, like the Gen 2 from Daimler and the Mirai from Toyota. Those global OEMs has also made their carbon neutrality announcement. Next application scenarios is the hydrogen storage. Compared to those batteries or the super capacitors, is only the seconds, minutes, or hours stays the storage. But with hydrogen, the storage time increased, and the stored energy also increased from kilowatt hours to gigawatt hours. So there's a internet there from the hydrogen production to hydrogen storage, and then will transport from the power grid and then to hydrogen refilling stations to the industry sector and to the stationary power grid. There is from power generation to power grid and then to power usage. The last application case is the architecture sector. The stationary power generator or SPGs can be applied to a wide range of scenarios, such as hospitals, supermarkets, factories, hotels, apartments, villages, and islands with 2 megawatt system, megawatt level solar and wind power storage. The stationary power generator has a lot of features as it has a higher efficiency. The system maximum efficiency is more than 58%, and the combined efficiency is more than 85%. Besides that, it's very clean. It's a green, zero emission, and zero pollution. It has a high adaptability. The temperature range is from minus 35 degree to 55 degree, and the utilization altitude is 3,000 meters. Also, it has a long durability. The operation is 40,000 hours, and the standby time is 15 years. Last, we will talk about hydrogen safety. For the hydrogen purposes, that hydrogen is very important. From the physical level, it is colorless, is tasteless, odorless, and is very light. From the chemical perspective, the explosion limit compared to gasoline or gas that has a higher range from 4.1 to 75, and the diffusibility is also higher than the gasoline and the gas, so it's not that easy to explode. But with that, we still have to care about hydrogen safety and to take measures. From the intrinsic safety, we can to care about the hydrogen features like it's colorless, odorless, flammable, and explosive. The material level, we can prevent hydrogen embrittlement, and the structure level, we can do more to have strength concentration, and the production level, we guaranteeing there's no production defect. For the proactive safety, we can first detection of hydrogen leakage and do have a risk assessment and alarming, and has hydrogen safety training. The passive safety measures is to stay away from leakage points, take emergency measures, and keep impact in control. From the vehicle level, we still have ways to do vehicle level hydrogen safety. There is like a V-shape measures, like from the vehicle design to system level design to component level design. And from this set, there is a vehicle level verification, system level verification, and part level verification. At the system design level, we can to have vehicle hydrogen leakage requirements, vehicle integration layout requirements, safety requirements for vehicle hydrogen exhaust, vehicle high voltage safety requirements, vehicle troubleshooting requirements. And at the system level design, we can have a release safety requirements, ventilation safety requirements, static safety requirements, system architecture security requirements, and as well as the system software security protection. For the component level, we can make sure the material safety requirements, sealing safety requirements, safety requirements for extreme working conditions, and installation protection safety requirements. For the vehicle verification, we will also mind the integrated analysis of suspension vehicle performance, the performance matching analysis of braking system, as well as we care about the strengths and the model simulation at the system level, ventilation effectiveness simulation, and bleed resistance matching. And then component level, we will care about the material compatibility test, hydrogen leak test, burst pressure test, and the insulation resistance test. Besides that, we will also do the integrated analysis, system level simulation, and also do the vehicle level computing and the calculation of hydrogen leakage and high pressure safety. This is a reference of the material used. Last part is about our company profile, Beijing Sino High-Tech profile. From the development history, Beijing Sino High-Tech was established under the name of Beijing Sino High-Tech in 2012. And after 10 years of development, we listed on the Shanghai Stock Exchange market in 2020. In 2021, we had a joint venture with Toyota, which is called Toyota Sino High-Tech Fuel Cell Company. In 2022, we serviced the Beijing 2022 Winter Olympic and Paralympic Games. In 2023, we became the first fuel cell company that is still listed in the Shanghai and Hong Kong Stock Exchange market. So from 2012 to 2017, our company is in a technology explosion stage, and Since 2019, our company has entered into a technology promotion stage. This is our group layout. In Zhangjiakou, we have the production line and the production base in Zhangjiakou, Hebei province. In Beijing, our headquarters is in there, and our R&D center, as well as the testing center, is in Beijing. There is also a production base in Daxing District, Beijing. In Shanghai, there is our subsidiaries, Beijing, the Shanghai Sinofusel. The company focused on stack is in Shanghai. After over 10 years of exploration and development, Sino High-Tech has expanded its business layout. So the main line is the Sino High-Tech. We focused on the fuel cell system, and as we said, our subsidiaries, the Shanghai Sinofusel, focused on the stack level, and there's also the Sino High-Tech hydrogen technology focused on the PEM electrolyzer. Sino High-Tech is a national high-tech company focusing on the R&D and the industrialization of hydrogen energy and fuel cell system. As a pioneer, the company has formed an internationally advanced and domestically leading product system of hydrogen fuel cell system. And the company has emerged as the first fuel cell company that is still listed in A+H stock. Our company was founded in 2012. Our staff is over 1,000, and the revenue is more than 740 million. And we are number one in compared market share. From the technology and product perspective, our R&D and investment in 2022, the company's R&D, production, sales, and other business basically remained stable and achieved a revenue of 738.11 million RMB during the reporting period, and the R&D environment accounts for 21.65% of the revenue. So it shows a upward trend. And this is the structure of our R&D personnel. For our system, this is the world's first more than 200 kilowatt single system vehicle fuel cell system, and it has a quick response, higher reliability, highly economical, and high integration. The rated power is 241 for the 240 kilowatts model, and the density is 757. The cold start temperature is -35, and the peak energy conversion efficiency is 58. There also the PEM electrolyzer is still also at a world-leading level in terms of economy, safety, dynamic responsibility, and environmental ability. For our fuel cell system, the 30 kilowatts to 240 kilowatts power range realizes a full coverage of the land transportation application scenarios. The stack is with independent R&D capability, achieves -35 Celsius degree low temperature startup and -40 Celsius degree low temperature storage. It's highly integrated and modularized design. It's very space saving, easy maintenance, and low maintenance costs. has a remote intelligent monitoring and diagnostic technology. It can have a real-time monitoring of the operation status, real-time intelligent diagnostic data. So this is from 2014. This basically the 30 kilowatt fuel cell system, and after more than 10 years exploration and development, in 2022 we launched the first more than 200 plus kilowatt fuel cell system. That is our 240 kilowatt fuel cell system. This is the product introduction of a PEM electrolyzer. It has wide load response range. The nominal power is 420 kilowatts, and the response range is from 5 to 150%, and the faster response, less the cost are also have a high pressure, high economy. Next is the product of a stationary power generator. 200 to 500 kilowatt stationary power generator can be applied to a wide range of scenarios, such as the hospitals, the supermarkets, factories, hotels, and apartments. Besides the R&D capability, we also have the leading testing capability. We have the system-level test bench, and also the environmental chamber, immersion tank, and the rolling tables to test for the fuel cell systems. And besides that, we also have the EMC test, waterproofing test, damped heat test, cold start test, salt spray test, noise test, vibration test, and durability test for our products. As for our production capability, in order to meet the rising demand for hydrogen fuel cell systems in the domestic new energy vehicle market, Sino High-Tech has expanded its production capability ahead of schedule and completed the layout of its production plants. As we said in our group layout, we have two production bases, like one in Daxing District, Beijing, and another in Zhangjiakou Hebei province. The one in Daxing, the annual capability is 3,000 units, but the one for Zhangjiakou in Hebei province is 10,000 units, and the combined production capability is maximum 3 gigawatts. This is our after-sales service that we can monitor the operation status of our fuel cell system within our platform. And we can track these fuel cell systems and provide solutions based on our platform and provide after-sales service. Next part is about the commercialization. For market leadership, after years of development, Sino High-Tech has taken a leading position in terms of market share, fuel cell electric vehicles announcement, and cooperative projects with OEMs. We know our market share is number 1, and our announcement is number 1. The cooperative project is also number 1, with cooperation with OEMs. This is a Zhangjiakou Hypo New Energy Technology company, And this is actually the first hydrogen production plant in China. And it has a continuous and safe operation for 3 years. It uses the renewable energies like the wind energy in Zhangjiakou. And next is the hydrogen refilling station Yinyufeng. And this is the China's first refilling station built in 2008 for commercial purposes and has a continuous and safe operation for 15 years. Sino High-Tech has involved in the construction and operation of the hydrogen refilling stations, including those 2 refilling stations and Chengdu Huatong hydrogen refilling stations. Besides that, we also have a rich operation experience. As of now, Sino High-Tech has provided power solution to over 5,000 fuel cell vehicles operating on the road in China, a cumulative operating distance of over 200 million kilometers. This is our operation in these cities. And our after-sale services support stations also cover the most of places and cities in China. After-sale services include 7 plus 24 hours hotline support and the all-weather fault diagnosis, repair service with supply of vulnerable parts, regular vehicle inspection and technical training, remote technical support, and background vehicle operation monitoring. For the application case, the first one is the 49 tons tractor. The driving range is more than 450 kilometers, and the operating vehicles now is more than 1,311. The cumulative operation is more than 10 million. And the 49 fuel cell electrical vehicles is jointly developed with OEMs, including the Chinese OEMs Foton, Yutong, Fiche, and FAW. It's mainly used in scenarios such as bus to railway transition, intercities, industrial park transition, factories transportation in large enterprises, and container shipment at ports. It's operated in a lot of Chinese cities, including Beijing, Chengdu, Zibo, and other places. Next application case is the 31 tons dumper. The vehicle info is the driving range is more than 400 kilometers. The operating vehicles is more than 360. And the cumulative operation is more than 11 million kilometers. And the hydrogen consumption is 12.33 kilograms per 100 kilometers. This 31 tons fuel cell powered dumper is jointly developed with Chinese OEMs Foton, Yutong, FAW, and Shenxi Automobile. It's mainly used in the construction sites transportation and operates in Beijing, Zhengzhou, and other places. The next application case is a 4.5 tons refrigerated vehicle. And the vehicle info is the driving range is more than 350 kilometers. The operating vehicles now is 926, and the accumulative operation is more than 10 million kilometers. It's mainly used in urban and suburban cold chain logistics and transportation scenarios, and also operate in a lot of Chinese cities, and works for a lot of logistic companies like the famous brand in China, Jingdong, Shunfeng, and Cainiao. Next is the 12-meter bus, which is also serviced in the 2022 Winter Olympics. Over 1,200 fuel cell electrical vehicles serviced in the 2022 Beijing Winter Olympics, 724 of which are equipped with Beijing Sino High-Tech fuel cell system, successfully empowering the transportation work. And it has a cumulative carbon reduction of 500 tons. And the cumulative operation is 10.98 million kilometers, and the cumulative operation hours is 40,949 hours. It achieves a safe and smooth operation experience in -30° and road conditions with an altitude of 2,198 meters and a slope of 16°. Yeah, this is basically a brief introduction of the hydrogen industry and the hydrogen development in China, as well as a brief introduction of our company, Beijing Sino High-Tech. That's all. Thanks for your time and listening.